You hear everywhere that the cool kids are using GraphQL for their APIs, and here you are, still building good old REST APIs, eventually starting to ask yourself whether you're missing out. When you are working as part of a backend team building web services, chances are that you are already quite familiar with REST. Using it for most, if not all, of your backend endpoints, naturally, you eventually might start asking yourself, is there a better way of building web services? Maybe there is a way in which I can improve things. Then you start hearing about GraphQL and that all the cool kids are using it, and you begin to think, maybe if I start using it, I will be just as cool as them. And now you are thinking about using it in your next API. But should you? Because I value your time, I will give you the answer straight away. No. Well, maybe. It kind of depends, but probably still no. But please hear me out and let me explain why. Proposing new technologies to a team can sometimes be a hard task depending on the attitude of your team. Some teams are eager to learn new things and are also encouraged by management to do so. Others have more the mentality of never touch a running system and don't really want to learn or try new things because they feel pretty comfortable with what they currently have. In those scenarios, you would be the troublemaker who interrupts their work as usual, and if the stuff that you introduce doesn't work out, you are the one to blame. In my opinion, this is not a healthy environment to be in, but I can talk from experience that those exist more often than I would like to acknowledge. Therefore, I would like to share my experiences working with GraphQL in real client projects, what I like about it, what I dislike about it, and whether I think you should use it for your next API. In my case, I didn't have a choice whether I would like to use GraphQL or not. At some point, I switched projects and the new project was already using GraphQL for all its backend web services. I've heard about GraphQL, but never actually looked into it or used it before. So I was naturally happy to add this experience to my toolbox. But to be honest, not long after me starting using it, I kept finding myself asking questions like, where is the benefit and isn't it too complicated for what it is? Let's take a step back and look at the value proposition of GraphQL. When looking up the benefits of GraphQL, these three things come up the most. When querying a REST API for an entity, you typically get the whole entity just the way the developer designed it, with all its properties, whether you need them all or just a subset of them. With GraphQL, on the other hand, just like the select statement in SQL, GraphQL enables you to specifically decide which fields you would like to receive from an API. REST web services are typically built around entities, and each entity is usually represented by an endpoint. And so it can happen that for a client to be able to display a specific page, it would need to issue multiple queries to the backend to fetch the required entities from various endpoints. GraphQL, unlike REST, usually only exposes one single endpoint that contains all the entities from the business domain. Therefore, you can have a single query fetching all the entities for your use case. This is made possible by field resolvers, which can be used to only compute the responses for the fields that have been actually queried by the client. GraphQL uses a strongly typed schema to ensure that clients only use valid queries to fetch data, and also to provide helpful error messages. And also clients can use those types from the schema to avoid writing manual parsing code. There are two approaches to schemas in GraphQL: code first and schema first. In the code first approach, you write code annotated with schema information, and then the schema gets generated for you. With the schema first approach, you write the schema and then the code gets generated for you. But you always need to provide some sort of schema. Now you might say, but Joe, this sounds awesome. Why did you say earlier that I probably shouldn't use GraphQL for my next API? Okay, so then let's talk about my experiences using GraphQL in my current project and about the things that I learned along the way. But before that, I created a new Discord server and it would be great if you would join. I really tried to get to know you better and yeah, just join and hang out a bit. We can talk. Probably in the beginning, there won't be many people, but also hopefully that will change over time. So yeah, join and let's hang out. In my current project, we have two kinds of web services. We have BFFs, which means backend for frontend, and some real web services that are not tied to a specific frontend, but rather model and represent some business domain functionality. And both types of web services are implemented using GraphQL in our case. Let's talk first about the no under or overfetching point. To be honest, in my opinion, this selling point sounds good and everything, but as long as you consume your own services or your data model isn't very complex, it doesn't really matter. In the BFF example, we as a team exactly know what the frontend needs to display everything, right? So therefore, we would build the backend to perfectly fit the need of the frontend. And that's basically also what it's for. That's why it's called backend for frontend. There will be no over or under fetching, since the backend is built specifically for the frontend. When you read about GraphQL online sometimes, the point comes up that using GraphQL, the frontend team doesn't need to talk to the backend team because it can check out the schema and pick what it needs. And I have a strong opinion on that topic. Why should it be good that the frontend and backend teams don't talk? Talking and collaboration should be encouraged and not prohibited. Also, the backend team usually doesn't just expose functionality or fields just in case the frontend will need it, but the API is usually built because of some specific requirement, and every field in the response is there because of a specific requirement. So if the requirement wasn't there yet, then the field won't be there for the frontend team to use. So at least for this case, the idea sounds good, but in the real world, it doesn't really help that much. Also, to be completely honest, so what if a few properties are in the response that are not needed? In the grand schema of what is properly loaded in your application, those few fields are probably your least problem. And if it is really a problem, you could implement a filter using query parameters to select some fields, just like the YouTube API is doing it. Yes, you would be re-implementing what GraphQL is doing out of the box, but you would also introduce less complexity, as we are going to see when discussing the other selling points. Getting everything in a single request sounds awesome, not gonna lie. But then when you start thinking about the implications, one might again start thinking, is it really such a big deal? When you want to fetch everything with one single request, that means that you need to design a data model that allows that in a sane way. And as it happens to be, this isn't such a trivial task at all. Most people tend to have an easier time focusing on parts of the data model and implementing them in separate endpoints. That, and because REST is around for longer and most developers are more familiar with it, is a reason why GraphQL APIs sometimes end up looking much more like REST APIs, where several different endpoints are modeled via different queries to actually emulate what REST is doing by default. This is also what actually happened in my current project. So instead of having one data model and one request to fetch everything, we have basically multiple endpoints to fetch parts of the data model. And yes, you might say it's your project's fault to use it wrong. And you would be maybe right, but I would argue that that also might be a symptom of a more general problem. Modeling a more complex data model where GraphQL actually would start to make sense, as it turns out, isn't that trivial. Besides thinking about the schema itself and proper relations and nesting, one needs to also think about the third-party systems involved to compute the response. One needs to do this to try to encapsulate them smartly in field resolvers so that those calls only happen when the field that relies on them is actually queried. And with nesting, lists, and such things, that gets increasingly challenging in a complex data model. Also, creating nested resolvers is quite cumbersome and gets confusing fast. Nested resolvers do not share state per default, so you might end up having to call downstream services multiple times, because you can't just call them in the parent and use the result in the children's out of the box. There are ways around this like data loaders, but again, it is increasing complexity. Also, when not using mechanisms like data loaders, nested resolvers that model a N-to-1 or N-to-M relation, that is where the parent resolver returns a list and the child resolver needs to be executed for each item. Those aggravate the N+1 query problem, since there is no way of aggregation or batching per default. So I hope you see that even when the concept of getting everything with one single call is a really nice concept and it definitely has its use cases, it also brings a bunch of challenges. And this is not to mention other things like, what is if somebody requests all the fields all the time? Will this DOS your service? Rate limiting in GraphQL also isn't as straightforward as rate limiting in something like REST, where you can have separate rate limits per endpoint, depending on how much processing is happening there. With GraphQL, to implement rate limiting, you need to calculate the complexity and costs of the different queries somehow. And yes, there are solutions for that, but again, they aren't as straightforward. And there are also some other annoyances, like for example, caching, monitoring, file uploads. I mean, everything is possible, but it's just not as straightforward as one might hope. Having a strongly tied schema is nice, but on its own, it's not a real reason to pick GraphQL in my opinion. Especially in cases where the data model isn't that complex. And yeah, I have the feeling that I already talked about the scenarios where the data model is more complex. You can also have schemas in other technologies using things like OpenAPI and Swagger, which provide schemas for REST web services, which will also enable you to auto-generate clients and so on. I hope you see that GraphQL definitely has its place and also has its benefits, but like most things in life, also comes with its set of challenges and shortcomings. Whether it is the right fit for your next API depends on your use case, your API, and also on the team working on implementing that API. I would argue that for most use cases, GraphQL is probably overkill and just introduces additional complexity in the day-to-day work, with little to no actual business benefit. In my opinion, GraphQL really shines if you plan to expose your API to many different consumers and you cannot know upfront what they will use it for, and when your data model is on the more complex side, or has the potential to evolve into a more complex data model over time. Since the schema in GraphQL acts as a guideline on how to use the data model properly in this case. If everything is done right, GraphQL is in my opinion better than REST, since it solves some of its shortcomings. But to do everything right, you will introduce a lot of complexity, so you need to decide whether your web service or use case is big and complex enough so that the cost is worth it, both in maintainability as well as in development speed. If you like this video, you might also like this video in which I explain how to properly unit test a web service. And also, it would be awesome if you could go completely crazy on the like button. And don't forget, there is a Discord server now, so check it out. See ya.